All right. Good morning, ladies and gentlemen. Uh, so today we're going to finish the last piece of graphing and writing equations with our graphs. So first we did graphing. We were given slope-intercept form, and we graphed the line. Second, we were given not slope-intercept form. We had to find slope-intercept form, right, and then graph it. Then we moved into taking a graph and writing it in slope-intercept form. And then we were given point and a slope, and we were able to use point slope formula instead of slope intercept form to find that. And now we have the last piece of the puzzle where we aren't given the slope, and we're given 2 points. So that's going to be kind of our last one. But let's do a refresher first from last week. So the first thing we did last week was something like this. This is point slope form. You'll notice up here, this y, everything in red here never changes. Everything in red does not change ever. That's our perfectly precise. It's always there. Y's are y's, minuses and equal signs stay, parentheses and all that. But then our x1, y1, these green values here, these are what's going to change based on our point. That's the point part of point slope form. And then our m is our slope, so we'll have to change our slope as well. Okay. Left a lot of space here. So, for example, they used to give us, or last week, they were giving us a point and a slope. And all we really need to do is take these and put our x1 into x1 up here and our y1 into y1 here and our slope into our slope. And they're nice and color-coded here, so follow your colors. But if we plug these straight in, what happens? Well, we get something that says like this. Y minus, the only careful part we need, it's going to be y minus y1. Our y1 here was -3, so it says y minus -3. Be careful. If you're getting super comfortable, you might be able to switch this to a plus right away. I like to write minus negative and then switch it all afterward. Just so I'm a little careful here. And then our m, our m here is replaced by our slope, -4. And our it says x minus x1, x minus, and x1 was +2, so x minus 2. Boom. So now we just need to take that and solve for y, so we get it in slope-intercept form so that we can graph it easier. Right? All right. Well, so all I did here is I took -4 and I distributed. I said -4 times x is -4x. -4 times -2 is a +8. Great. And then I just did plus positive over here for y plus 3 instead. Right? If you just wrote y plus 3 here because you knew you were going to have to switch it, that's okay. We're kind of to that point where I would expect some of us to be doing that, but not all of us. So I won't be doing it just to kind of remind you of what it looks like, but some of you might end up wanting to do that. And then I subtracted by 3 on both sides, right? We're trying to get y by itself, so I said, nope, get out of here, 3. I need you out of here. Y equals -4x plus 5 now. 8 minus 3 is 5. So that's what we did yesterday, or Friday, I guess, and last week, a bunch of those days. So we've been working on this for a while. So now we're going to see what happens when they don't give us this slope. The hardest type of problem they can do is they just give us 2 points. So we're going to talk about what that is, because first we have to find the slope, which we can do. We've done that, so we can find the slope, and then use that to then plug it in with either of the points. All right, so let's see how that works out. Okay, so once again, I have the slope, point slope formula up here. We'll use this in a minute, but it's actually kind of written out of place because we're not going to need this for a minute because it says we need to find the line that goes through -3, 7, and 1, -1. -3, 7, and 1, -1. Well, so we need for this a point, y1, x1. Well, we have 2 points. Those are cool. So we could use either one of these points when we plug in here. Any point on the graph would do. So we could plug either of those in. But we need the slope. We're not given the slope, right? We have just 2 points here. So what are we going to have to do? Well, let's label x1, y1, and x2, y2 so that we can plug this into our slope formula. So we can plug this into our slope formula, right? We remember this? We did this y2 minus y1 over x2 minus x1. Hold on a little bit. All the way to there. Y2 minus y1 over x2 minus x1. This was just to find the slope. We'll get some fractions, maybe sometimes some whole numbers sometimes, and then we reduce it, and that's our slope, right? So I did it here. I said y2. Well, y2 is -1 minus y1, 7, -1 minus 7, okay? And then x2 here is 1, boom, minus, boom, and x1, well, that was -3, so I said minus -3. But remember, when we eventually do that, we're going to say y plus 3 is the same thing, right? Plus a positive here is the same thing as minus a negative. Cool. So -1 minus 7 is -8. A +1 minus -3, or 1 plus 3, is a +4. And that is equal to, then, well, -8 divided by 4 is -2. Cool. So we have our slope, right? And if you look back up here, all we needed was our slope and a point, y1, x1, x1, y1, right? And we can use either of these two. I think I'll end up using this one just because it's the first point I labeled, but you could just as easily use this one if you tried it, but I'll probably use this one first. So we're going to take these values to plug them in for x1, y1, and we're going to take this value and plug it in for the slope, and we're almost done. So let's see what that looks like. Once again, everything in red is exactly the same every single time. Y minus, the equal signs, everything like that. We just placed y minus y1. Well, what was y1? Y1 was 7. Boom. Y1 was 7. Y minus 7. Cool. That makes sense. Equals -2. I just took that slope, bang, put it down here. Times parentheses x minus, well, what? Well, minus -3. X minus -3. Be careful. We will want to change that to a positive. I did that in a whole step. Honestly, if you just put plus positive and then distribute, that's fine with me for showing work and stuff. I just like to be slow and concise so that everybody can see what I'm doing. So from this step to this step, all I did was change this to a plus, which is a little extra, but that's okay. So then I multiply -2 times x, -2 times 3. If you do, boom, y minus 7 is equal to -2 times x, -2x, minus 6. -2 times 3, don't switch your signs. -2 times a +3 is a -6. All right, and then just add that 7 over. If you add that 7 to both sides, boom, we get +1, -2x plus 1. Wow, beautiful. All right. So that is kind of the big picture, right? So let's just like bot through back what we did here. We said, hey, I need this formula, but I need a point and a slope. And right now they're giving me 2 points. So what do? We have to find the slope, right? We have to find the missing piece. The missing piece in this case is the slope. And so we're going to do that by using the slope formula, y2 minus y1 over x2 minus x1. We did that. We found the slope, bang, and then we plugged in the slope. And one of the points, once again, either point would work. I just chose the first one. I think the next example I chose the second one because it doesn't matter. And then we plugged it into here. And then solving for y shouldn't be terribly difficult. It's probably just this part getting set up to here. Okay, so I'll do 2 more examples. Make sure you're asking questions as you go through. If you have them, I'll be around. Make it happen. All right, so 2 more examples, just so you have enough clear, concise examples to look through while you're practicing. Once again, it just says, hey, through this point, -6, -7, and 3, -4. These 2 points, and we need to go through both of these points, which we still need then the slope, and then we'll use one of these points. It doesn't matter which one, but we need the slope before we can keep moving. So to find the slope, I like to label x1, y1, and x2, y2 right away, so that when I plug it into the formula, y2 minus y1 over x2 minus x1, that they become pretty straightforward, right? We just plug them in. Y2, well, y2 is -4. Boom. Minus the red minus sign. Y1, well, Y1 was -7, so this is kind of what I'm talking about. If you just, instead of saying minus -7, you just go straight to a plus sign, that's okay with me. I kind of expect this by the 5th time we do these to be able to see. We're always taking the opposite sign, right? If it says minus a negative, we're going to just change it to positive. So that happens on both of these. Similar, x2 is 3 minus, red minus sign. X1 is -6, so it ends up being +6. You're always going to do the opposite. Okay. -4 plus 7 is a +3. 3 plus 6 is a +9. And 3 over 9 can be reduced if we divide them each by 3 down to 1/3. So this is our slope here. This is our slope, 1/3. Okay. Don't be afraid of fractions. Once again, we expect fractions in these problems because a lot of our slopes are fractional slopes, right? So we expect slope to be fractional sometimes. It's okay. All right. And so down here, Now we see this formula once again. We're going to plug in a y1 and an x1, and we're going to plug in our slope. I think I take these 2 points just to prove to you that you can. If you took these two these points, this 1 point with 2 values, you plugged these in, you'd get the same thing once you solve for y, I promise. I just use these just to, one, they're smaller numbers, so sometimes that's nice, and two, I just wanted to prove to you that you could use either. So I'll plug these in. So we'll be taking the 3 and plugging it in for x1 here, and y2, well, we're going to plug that in for the y1 here. I just grabbed the second point instead of the first. But either way, it's still the x and the y that we're changing in there. Okay. So once again, y minus, well, y1, well, we're taking this one, -4, y minus -4, deal. And 1/3, that came from here, times x minus, well, x minus x1. We're taking this point, so our x value from this point is 3, x minus 3. Boom. So I took -4, plugged it in for y1, +3 plugged in for x1, and our slope plugged in for slope. Sweet. So now we just need to distribute this. Remember, if you're doing this, you can use your calculator. You can use do it by hand. You're doing top times top over bottom times bottom when you're doing this. So this would be 1/3 times 3 over 1. You end up just getting 1. We didn't even distribute it yet. Once again, the whole step from here to here is just to change this to a plus sign. So we're working with nice clear stuff. And then if I distribute 1/3 times x is 1/3 x. 1/3 times -3 is -1. You can try it in your calculator, Google, you just do it. It works out pretty straightforwardly. No, Google, I'm still not talking to you. And finally, to get y by itself, we need to get rid of that 4. So if I subtract 4 on both sides, boom, we subtract 4 on both sides, -1 minus 4. Whoa, that's a -5. All right. Give me my pen tool. Where's the pen tool? Set this up to my, there we go. We need something nice and bright. That is a -5. Ooh, big mistakes, Mr. Kleckler. -5. Whoopsie. That's okay. All right. -1 minus 4 is -5. See, mistakes happen. Life goes on. We can overcome those. Okay. Whoopsie. Ooh, this still gives me the pen tool. That's nice. All right. So that is that problem with one little mistake in it that we caught right away. So that's okay. All right. So let's do one more, the last one. It says we need through, oh, it's kind of like a pointer now, right? We need through 2, -1, the point 2, -1, and 4, -6, okay? So once again, we have 2 points. So we have half of what they need for the point slope formula. We just need the slope part. We have 2 points. Point part is covered. We need the slope part. Okay, so I like to label x1, y1, x2, y2. Once again, just make sure you're labeling these up so that when you plug them in, you're in good shape. And so if I do y2 minus y1, well, y2 -6, -6, minus y1 minus -1. Boom, that's why it already says plus a positive. Okay. And x2, 4 minus x1. X1 was 2, 4 minus 2. Well, 4 minus 2 is 2. So -6 plus 1 is -5. Be careful with your signs and adding. 4 minus 2, you should all know that that's 2. So we can't even reduce that. We're just done at -5 over 2. That's our slope. That's great. We have a slope. We have an m done there. So now we need to go say, hey, let's plug this in for m. Oh, yeah, I don't need to do that. This is in for m, and either of these 2 points, I think I use x1, y1 here. I use my first point, but once again, you could just as easily use 4 and -6 as long as you're plugging them in for the x and y correctly. So we'll do y minus y1 equals m times x minus x1. What am I writing? Jeez. I'm telling I made these notes a little late last night. Whoops, there we go. Easy fixes, right? Y minus y1 equals m times x minus x1. The same formula we've been using for the last 4 examples. My mistake. So if you do that, well, we're going to say y minus What's y1? Y1 here was -1. So y minus -1 deal equals m. Yeah, this is the one here too. I just wrote m again, so I'll plug that in the next step. Times x minus x1. X1 here is a 1. Great. So we'll plug that slope in. This example I rewrote like 6 times last night. So I messed this up, but I said, you know what, we're just going to do an extra step. That's fine. So y plus, I changed this to a plus, right? Because this is a minus negative again. Plus, plugged in my m, x minus 2. Cool. So we'll need to distribute this. We'll distribute this into here. That's okay. These fractions will tend to work out, right? If we do that, y plus 1 still is equal to -5 halves times x is just -5 halves x. That didn't change. That's the same as like 2 times x is 2x. -5 halves x times -5 halves times x is just -5 halves x, right? We're just kind of putting that with the variable. That's okay. And then -5 halves times -2, once again, essentially the bottom here cancels out and we get a +5. Negative times a negative is a +5. Cool. So then we just need to subtract 1 on both sides. Subtract 1 on both sides, you end up with y equals -5 halves x plus 4. All right, that was 3 examples of almost the exact same thing. Hopefully those are helpful. These are by far the hardest problems that we're going to do because you have to first find the slope and then use point slope formula, which is a little less familiar with us than slope intercept form. And you'll also then need to solve for y afterwards. So make sure you're solving for the slope intercept form of these equations. Okay. This whole time I'll be around to ask questions for us, so make sure you're asking questions. And yeah, nice job. Get it done today, and we're gonna test this week. So exciting stuff.